This video is covering section 3.2, the mean value theorem. Okay, this one is a really important video, so make sure you pay close attention. Mean value theorem is one of the biggies. It is one of the theorems that you're going to need to know backwards and forwards. So this whole thing right here is going to need to be memorized. Alright, so make sure you mark your notes accordingly because this is very, very, very important. Alright, so now we got that. Let's look at the mean value theorem. Again, this is a theorem, so we have an if-then statement. So it's very important that all the conditions are met before we can assume the then part. So let's look at what we need. We need to know that a function is continuous and differentiable. Remember, if a function is continuous, that does not mean it's differentiable necessarily. Okay, so if a function is differentiable, however, then we know for a fact that it's continuous. So if a problem says that a function is differentiable, then we know it's continuous. However, if the problem just says that the function is continuous but does not state differentiable, we cannot assume that. So you've got to be careful there. Alright, so if f is continuous, and here's something important that you need to notice. It has the interval from a to b for both continuous and differentiable, but there's a difference. For continuous, we have closed brackets. That means a closed interval. Differentiable is on the open interval. The reason because of this is continuous, I can have my points be defined at a and b, but differentiable, I can't really have a derivative at an endpoint. So therefore, that is an open interval. That's important to note. So if all this is true, then there exists at least one value of c on the interval from a to b such that all of this stuff. Okay, so we're going to talk about what this means right here. Alright, so we have f prime of c equals f of b minus f of a all over b minus a. What does that mean? So we're going to look at a picture first, then we'll come back up here. What this means is, first of all, f prime of c is a derivative. And when we talk about a derivative, and especially when we talk about like position, velocity, and things like that, a derivative is an instantaneous rate of change. That means think of the rate of change at one point. And we're going to use, for the sake of this problem, think of the slope. So think slope at a certain point. So if you're driving down the road, instead of finding your average rate of change by taking your distance divided by your time, then you could just, you would want to know what your exact speed is at a certain time period in the interval. And then that's being compared to the average rate of change. Okay, so an average rate of change, what I just said, is if you're driving, and I said I traveled 60 miles in 1 hour, how fast was I going? 60 divided by 1 is 60 miles per hour. Was I going 60 miles per hour the whole time? Probably not. Okay, so at any given time within that hour, I might have been going 30 miles per hour, 80 miles per hour. Okay, so what the mean value theorem states is exactly this. The instantaneous rate of change equals the average rate of change. Another way of thinking of the average rate of change is the slope between 2 points. So whereas the average rate of change, I've got two pieces of information. I find the slope. The instantaneous rate of change is the derivative. It's the slope at a certain point. Okay, another way of thinking of this, below the graph here, is the slope of the tangent, because that's at 1 point, equals the slope of the secant line, which occurs at 2 points. So now that we look at this function, we have this function f on the closed interval from a to b, and it is continuous and differentiable. So if I think of the average rate of change, that means the slope between 2 points. So that is, if I draw a line between these 2 points, and I know I did not connect them, but pretend that they are connected, then this right here is the secant line. Okay, and so what that says is whatever this slope is, this has some kind of slope. And how would you calculate that slope? Well, you would calculate it by finding your slope formula. F of b minus f of a is just simply your slope formula. y2 minus y1 over x2 minus x1. That's essentially what it is. So this secant line has a certain value of a slope. Then somewhere within this interval, there are other places where I have a tangent line at a certain point where the slope is exactly the same. And you can kind of see it. If I trace along here and I have a slope kind of like that, right at that point, that has about the same slope as the secant line slope. If you can continue going and imagining kind of this line following along, we have another one that occurs about right here. So the slope is about, we're looking for parallel tangent slopes. And continuing on, it looks like we have another one right about maybe here. Okay? So this, within this function, I actually have 3 places. So we're going to call this x value, where that first one occurs, C1. Then we're going to call this one, the second one that it occurs, C2. And the third one is going to be C3. Okay, so the mean value theorem says there exists at least one value, and this one actually has 3. So it guarantees at least 1. So I've got these different places at which my speed, or my instantaneous rate of change, is exactly the same as my average rate of change. Okay, so let's look at another thing. Remember, with the theorem, it's very important that we have that if part satisfied. So what if that if part is not satisfied? So let's look at this example. That is, if we drop the differentiability requirement, if I'm not differentiable. We talked about in the video lesson 3.1 that at a cusp, you have continuity but not differentiability. So if I set a function as continuous, but I don't guarantee differentiable, I could have a situation like this. So if I were to find the average rate of change here, or the slope between the 2 points, and I found that slope, is there any place in here that has that same slope? Well, no, it doesn't. Some people try to make this right here the same slope, but this has undefined slope. So therefore, there's no place within this interval at which the slope of the secant is the same as the slope of the tangent. So the mean value theorem fails because we did not guarantee differentiability. Okay? So let's look and see how this looks like in a typical problem. So this is asking for finding all the values of c guaranteed by the mean value theorem for this actual function. So that's saying if this was our function here, they want to know what each of these c values are. And they have to be within the interval. So we're looking at just the interval from 0 to 2, so our c values are only going to be between 0 and 2. All right, so just to restate the mean value theorem, we want to know that f prime at c is equal to f of b, which here is 2, minus f of 0 all over 2 minus 0. It's simply just finding the slope between those 2 points. Okay, so what do we need to do? Well, we need to find our derivative, and we also need to evaluate f of 2 and f of 0. So first of all, let's find the derivative. So f prime is going to be 3x squared minus 2. And then I'm going to go ahead and calculate what f of 2 and f of 0 are. So if I plug in 2, not into the derivative, into the function, you get 2 cubed minus 2 times 2. So that's going to be 8 minus 4 is 4. And then f of 0 is just 0. Okay, so this is all my preliminary work. Now I'm going to take my mean value theorem statement and set that equal. And actually, before I do that, let me go ahead and clarify. I did not check the if part. Remember, the if says that the function has to be differentiable and continuous. This is a cubic function, and all polynomials, so regular cubics, quadratics, things like that, are both continuous and differentiable. So we're good there. But I needed to mention it because sometimes you don't have that, and you've got to watch out for that. Okay, so now I'm going to apply my mean value theorem. So that says that the derivative, which I have is 3x squared minus 2, is equal to f of 2, which is 4, minus f of 0 is 0, over 2 minus 0. Or in other words, 3x minus 2 is equal to 2. So now we need to solve this. So that's going to be, if I add 2 divided by 3, we get x squared equals 4/3. Take the square root. Remember, when you take the square root, your answer is both plus or minus. 2 over the square root of 3. So those are the two places where I would have the same slope as the secant line. However, we're only on the interval from 0 to 2, so that only includes the positive value. So we're just going to look at the positive 2 over root 3. So x equals positive 2 over root 3 is the value on the interval from 0 to 2, guaranteed by mean value theorem. And I'm going to go ahead and throw in here for good measure, because our function f is differentiable on the interval from 0 to 2. We want to make sure we tell whoever's grading our paper, that would be me, that we understand that we checked for that if part. And I did just state differentiable, I didn't state continuous, because differentiable implies continuity. Okay, our last example, very easy. This just says how many points on the interval does the function shown satisfy the MBT. Again, satisfy the MBT, we want to think, is the function continuous and differentiable? Yes, it is. There's no cusps or anything like that, so the MBT does apply. So we want to know how many points does the interval in the interval does the function satisfy the MBT. Okay, so this is not very good at drawing lines, so I'm going to do the best I can. So the first thing you want to do is draw your secant line. So this is the slope that we're looking for. We're looking for tangent lines that have the same slope. How many of those are there in this interval? So there's going to be one about right in here, and then another one about right in here, and that's about it. So there's 2 values guaranteed on the interval from A to B. I'm going to say by mean value theorem, because g of x is differentiable on the interval from A to B. Okay? And that's it. That's the mean value theorem.